Ladies and gentlemen, boys and girls, cats and kitties, hippies and squares. My name's Court, and we're here at the end of the fifth part of your exam review, so congratulations for making it this far. So we're going to start here on problem 174. Let's talk about it. Given an right here is the nth term of a sequence, write the first 5 terms of the sequence. Okay, well this isn't so bad, right? Because we start with n equals 1, right? Go 2, 3, 4, 5. So let's just plug in those values for n. So our first value then will be 3 times 1 squared plus 2, right? 3 times 2 squared plus 2. 3 times 3 squared plus 2. 3 times 4 squared plus 2. Running out of room. 3 times 5 squared plus 2. And what we're going to do is, of course, just put all those values in the calculator. And so I'm going to fill out more space for it here. But you put them all in your calculator. I'm going to write them over here to the left. So this will give us A1 is 5, A2, 14, A3, 29, and yep, 50 and 77. So that's it, see, easy peasy. So not so bad. All right, so let's move on to number 75. Given this is the nth term of the sequence, find the 20th term. Now that's not so bad at all. If we want the 20th term, n would be 20, right? So then, A20, what we're looking for, 5 over 20 minus 1. Right, so I believe that that is a 1/4 minus 1, right? Equals negative 3/4. And that's our 20th term right there. Nice, not so bad. All right, on to number 76. First 5 sequence of terms of the sequence defined recursively. That sounds really scary, but I guarantee you it's not that bad. Well, this means, right, we have our information here that A1 is 30. Well, this means we need to use this equation to find the subsequent terms after this, right? So this would mean that A2 would equal 1/3 A2 minus 1, so that would be A1, right? Let's write this out. So this would mean if we plug in 2 for n here, A2 equals 1/3 of A n minus 1, right? Well, 2 minus 1 is 1, so that A1 minus 1. Well, this means if we want to find A2, we got to take our value for A1 here and plug it in there. And what do we get? We get, oh, whoops, what did I do? Follow that? Oh my goodness. Hello again, it's me from the future. I fixed my pen. But anyway, we're going to go ahead and plug this A1 directly into that little recurrence relation. That's what this kind of thing is called right here. This is called the recurrence relation. Sounds scary, but it's not. Don't worry. So anyway, we plug that in, right? And so then we get 1/3 times 30 minus 1. This would be 10 minus 1 equals 9, right? Anyway. So that's not so bad. So that would be the second term of the sequence defined recursively. So then we would do the same thing a couple more times. I'm just going to erase it just to make some more room here. How does this eraser work? Yes. I'll erase just to make a little bit more room here, and then we'll do the other one. Remember, we just found A2 is 9. So anyway, well now what we do is 1/3 times 9, right? Minus 1. Well, this would be 3 minus 1 equals 2, right? Okay, so A3 is 2. Now let's do the same thing, but we're going to plug 2 back in this time. So 1/3 times 2 minus 1. Well, this would equal negative 1/3, right? Nice. So that means A4 negative 1/3. Let's just do it one more time. So 1/3 times negative 1/3 minus 1. That would equal negative 1/9 minus 1. So this equals, what would this be? Would be negative 1/9 minus 9 over 9. Negative 10 over 9. And that there is a 5. Oh, where'd my pen go? So there we go. We just wrote the first 5 terms there. Maybe it would be nice and pretty if you wrote them out as a set. Of course, after I find a more efficient way to erase. Oh, that was ugly. Yeah. So 30, 9, 2, negative 1/3, negative 10 over 9. Boom, that's the first 5 terms. All right, now let's move on to 77. We're evaluating these. Factorial, what does this exclamation mark mean? 8! No, not quite. This simply means, you might remember, you multiply by going down each one. 8 times 7 times 6 times 5 times 4 times 3 times 2 times, you guessed it, 1. So we can put that in our calculator. You can, some calculators, I don't know if yours does, but actually just straight up has that exclamation mark that you can type. Or you can put this in your calculator manually. That's fine too. What you should get is a pretty big number, like 40320 perhaps. So 40,320. That is the value of factorial, 8 factorial, sorry. So you might notice these numbers get pretty big pretty fast, and that's okay. That's correct. 12 factorial over 6 factorial. Well, we're going to do the same old thing here, right? This time we have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 6 times 5 times 4 times 3 times 2 times 1. So if you go ahead and throw all that tosh into your calculator, you'll get back 665,280. So there we go. All right, so what about this last one then? What do we do with these exclamation marks in between? Well, that's just them multiplied by each other. So let's go ahead and do that one. I'll do some erasing first though to create some room. Anyway, so yeah, this one would be 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over these, which would be 6 times 5 times 4 times 3 times 2 times 1. That multiplied by, because they're sitting next to each other, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yep. And then, of course, again, throw all of it in your calculator, which I am doing presently. And you should come back with 3003. Yep. Excellent. That's not so bad. Okay, on to 78. Find the following sums. Oh, we're going to find them. Don't worry. This first one you can actually do by hand pretty easily without using your calculator. So let's go ahead and try to do that. All this fancy stuff, this sigma right here, this just means that you're just going to take this, right? You're going to put in 1 for I. Then you're going to add, doing the same thing, but put in 2 for I. And you're going to keep doing that until I is 4. Yeah, so what would this be? Well, this would be 4, 1 for I, right? Plus 7. That's our first term, right? Plus, now we're going to do 4, 2 for I, plus 7. Plus 4, again, times 3 for I, plus 7. I'm just putting these brackets around them to separate the terms. I'm running out of room here. And 4 times 4 for I, plus 7. And you can add all that in your calculator. I'm going to do right now. So 4 plus 7, that's actually just going to cut 68. That's what you get. Now these next ones are a little more tedious because we have more than just 4 terms. Of course, you can do them by hand. It's up to you, but I'm also going to let you know that there's a little function on your TI-83 calculator to allow you to do exactly this. So if you would follow along with what I'm doing, I'm going to write out here to the left what you can do on your calculator to compute these. So here's what you got to do. You open up your calculator. You hit second. Then you hit stat. After you hit stat, you go over to math. And once you're there, go to number 5, which is sum. Then hit enter, put that in your calculator. Once you're there, you'll do something pretty similar. You'll hit second and stat again. So second, stat. This time, though, you'll go to ops. And then you'll go to 5 again. I wrote 2 arrows. That's hilarious. This should give you an option that looks like SEQ, stands for sequence. Okay, so you should have something inside your calculator that looks like this. We're on the same page? Nice. Now we're going to go ahead and type in this sequence right here in your calculator. So I'm going to write what I end up typing here. There's a button with X's. We'll just use X's because I actually don't know how to make in pop up on this calculator, and it doesn't really matter, so it's okay. So I'll hit X squared plus 2, and then raise the X bar. How about that? So calculator looks like this right now. All right. Now after that, you're actually going to put a comma in your calculator. And the next thing you need to tell your calculator is what variable you are talking about. In our case, we're using X. So we will type X in our calculator. And you're going to put another comma there. Then what you're going to tell your calculator is where you start, which would be right here. In our case, it's 2. So we'll put 2 in. Then next, you're going to tell your calculator where you stop. It's going to be 12. So we'll put it on 12. Then you'll close the parentheses for sequence, but you'll have to close it again because you got parentheses over here, right? Hit enter, and you should get back your answer. Hopefully that was somewhat clear. 8837. That is the value of this summation. Awesome. All right, we're actually going to run through it, I think, again. All right, now let's do part C. So we're going to run through it kind of one more time here. Just make sure we got it, because I have a feeling that wasn't so clear. Anyway, so let's follow along. First, you're going to hit second. Second. Stat. Now go to math. Number 5, sum. Hit enter. I'm going to do the similar thing again. Second. Stat. Now go to ops. then 5, SEQ. All right, and we have, looks like this in our calculator. Now we gotta type in the sequence, right? Which is this part right here. So let's go ahead and put that one in. So I'm going to type, this one might be a little unintuitive in the calculator. That's okay. I'm typing it in right now. And then I'm going to write what it looks like. So you can type it in also, or make sure we're doing the same thing. Yes, anyway. I typed in, looks like this. Make sure to put your exponents in parentheses on this exponent here, so you know it's all together. Yep, something like that. Then you'll put a comma, right? And we're going to list the variable we want, which is x. Another comma, then list where you start, which is 5, another comma, then we're going to list where you stop, which is 25. Close the parenthesis for sequence, close it for sum. And you should get back 290. Sweet, we did it. So let's move on, talking about more sequences and all. 79, find the common difference. Common difference is basically how much this is changing each time. Well, how much is this changing? Notice it's going down by the same amount every time, right? So, how much is it going down? What's 5 minus 12? Well, that's negative 7, right? Well, it's the same thing as maybe if we took the next terms, like negative 2 minus 5. Well, that's also negative 7. So all the same, right? It's changing by negative 7 each time. So our common difference is negative 7. Sweet. Not so bad. So next, number 80. Write the first 5 terms of the sequence given this stuff. Well, we start with negative 3, right? That one's easy. It just gives it to us, right? Then common difference is 5, so this means it's going to change by positive 5 each time. So negative 3 plus 5, what's that? That's 2. Well, that plus 5, what's that? 7. That plus 5, what's that? Well, that's 12. Plus 5, what's that? 17. So check it out. There's the first 5 terms right there. Nice. Next, 81. Find the number of terms of the finite arithmetic sequence. So this one might be a little tricky, right? But I think the first thing to notice is, where do we start? Well, we start at 8. How far do we go up each time? I'm going to write to the left here. So what's 14 minus 8? That'd be 6, right? What about 20 minus 14? That's also 6. So it's going up 6 each time. So we want to know, it might help to know how many times we have to go up 6 until we get 350. Right? So how far do you have to go from 8 to get to 350? So what's 350 minus 8? Well, that would be 342, right? How many times do you have to go up 8 to go up 342 total? Well, that would be, sorry, not go up 8, go up 6. That would be 342 divided by 6, right? What's 342 divided by 6? 57. So this would mean you have to go up 57 times from 8, right? This means that there are 57 terms in the sequence after 8. since 8 is A1, that would be 58 terms, right? So you start with 1, and then there's 57 more. Yeah, so there's 58 of them. Okay, last page, we're on the home stretch. Find the sum of the following finite arithmetic sequencer series. This one's pretty easy, right? We just take these and we add them up. Put little plus signs between them. Take that calculator and you get, drum roll, 91. There we go. See the next one. Hey, it already added them for you. Look at that. It already put the plus signs. I don't even have to write it. You just add all these up in your calculator and you should get 260. See the last one. So this one is kind of what we did earlier. It's written like this. So we'll do this in our calculator. Right, the same way. So I'll just talk through what we do this time. Second, stat. Go to math, go to sum. Now I'll go second, stat again. Back to math. Sum, or not sum, I'm sorry. Sequence. And ops. Second, stat, math, sum, second, stat, ops, sequence. Then we're going to type in what the sequence is. In this case, we'll type 3x minus 7, okay, comma, x, because we're telling it a variable, comma, 1, comma, 40. And then 2 parentheses on the end. And then that should give you back, why does it keep pulling that up? Should give you back 180. There you go. Okay, 83. Given A12 is this and A51 is this, find A172. So this kind of goes with the assumption that this is going to be sort of a linear sequence. So it's increasing by the same amount each time. Which is fine. So, I mean, let's think about it. AN, right? Some term of the sequence. It's going to be A1, the first value, right? And plus D, the common difference, times n minus 1 number of times that you go up. Right? So we can write a little system of equations here over to the right. I'm going to write it. So A12 equals A1 plus D times n minus 1. N is 12, right? So n minus 1 is 11. A51 equals A1 plus D, right? N minus 1, well, n is 50, so n minus 1 is, sorry, yeah, n is 51, so n minus 1 is 51. Well, we know A12 is 52, right? This one is 208. So then, I mean, we can do a little solving here, right? So let's take this last one, right? So I'm just subtracting over 50D. 208 minus 50D. Now we can plug this in right here. Right, so 208 minus 50D plus 11D equals 52. I just got to do just a wee bit of algebra to this right here. 208 minus 39D equals 52. Then I'm just going to add this, so 208 minus 52 equals 39D. So I think this is 156 equals 39D. Divide by 39. D equals, what do we get? 4. Okay, we have this information, so let's substitute it back in up here. So D equals 4. So then we'll go ahead and say A1 plus 4 times 11 equals 52. So A1 equals 52 minus 44. A1 equals 8. Okay, cool. So I'm going to write the information that we got over here. A1 equals 8, and D equals 4. So what about then A172? Well, we'll use this formula right here again. So A172 equals 8 plus 4, 172 minus 1, right? So this is 8 plus 4 times 171. I'm just going to throw that one in the old calculator here. This gives us 692. There we go. It's been done. Number 84. Starting position as this salary, a raise of this much per year. Find the total income if you work for 30 years. All right. Well, you can write this actually kind of like a sequence. Very funnily enough. In the sense that, let's say after you work for 1 year, you've made $60,000, right? But then the next year, after you get a raise, you get raised $3,000. So you will now make $63,000, right? So we can actually write this as a sum. So let's start with I equals 1, right? And we go up to 30 years. So we will have, for our sum, be 60,000, because that's how much you start with, right? Plus 3,000 times I minus 1. So now what we do is we can use this summation to go ahead and calculate the value. Basically, this means after each year, right, you're going to get a raise. So the amount of money you make the next year is going to be a little bit more. So here we can take the summation that we just wrote and put it in our calculator just like we have. So I've already gone through it a couple times. Second, stat, math, sum, second, stat, ops, sequence. Now we'll type in our sequence, which is right here. So I'll type in 60,000 plus 3,000, and then x minus 1, comma, x, because that's a variable, comma, 1, because we start at 1, and then comma, you guessed it, 30, because we go to 30. So, nice. And what our calculator should spit back out at us is this number here. So what does this mean? Well, this means that after you work for 30 years, you get $3,105,000 in total. So there we go. That's a problem. So next one, find the common ratio of the geometric sequence. So this is a spot where it might be helpful to turn in your book to section 8.3, where it talks about geometric sequences and series. So geometric sequence, the nth term, right, this is just a formula from your book, can be written like this, where R is called the common ratio, and A1 is your starting value, which in our case, A1 is 4, right, because we start at 4. So this just means that you multiply this number by something, you'll get this one. Multiply that by the same thing, you'll get this. Multiply that by it, and you'll get this. Basically, your result is being multiplied by something every time, and it's the same thing. That's called the common ratio. So in our case, you might be able to tell, well, 4 times what is 20? 4 times 5 is 20. 20 times 5 is 100. 100 times 5 is 500. Well, that means that that's our ratio. R is 5. Sweet. All right, let's move on. So first 5 terms of the geometric sequence given this information. Well, here, we can write a general formula using what we just talked about geometric sequence, right? So that would be a general formula. So let's plug in n equals 1, right? Then we'll get back 3 times 3 to the 0 power, which is going to be 3 times 1, so 3. Okay, then 3 times 3 to the 2 minus 1 power, so that's 3 times 3 to the 1 power. That's 9. Well, each one of these is just going to multiply by 3 each time, right? So it's 9 times 3, 27. 27 times 3. Gotta bust out the calculator here. 81. 81 times 3. 243. So there we go. Those are the first 5 terms of your sequence. Maybe write it in set notation like this. Sweet. There we go. 87. Find the sum of the geometric series. Notice this follows your same formula, right? Where A would be 4, A1 would be 4, right? And then 3 would be R. In your textbook, there are formulas for calculating the sum of a geometric sequence or geometric series. So right here, this is a finite geometric series because you notice it goes from 1 to 8. It doesn't go on forever. So the formula in your textbook is as follows, saying, I'll just write it out here for you. Right there. That is an R down there, not an N. Apologies about my handwriting. You've had to deal with it for this whole video. Anyway, so what is A1? Well, it's 4, right? So 4, you can tell because it's right here, follows your formula. Okay, now 1 minus R, well, R is 3, it's in here, right? 3 to the n power, right? Over 1 minus 3. And what's n in our case? How far are we going? Well, we're going up to 8, so that would be n. So now we can just stick that in our calculator. And we should get back 13,120. Excellent. Okay, let's talk about the next one. Next one doesn't actually give you the formula for the sequence, so you kind of have to figure it out on your own, but it's not that bad. Let's start with the starting value. What is it? Well, it's 1, right? So that's what we start with. And this is also a finite series, right? So 1 minus, well, what's R? It looks like R is 2/3, because notice it's being multiplied by 2/3 each time. 1 times 2/3 is 2/3. 2/3 times 2/3 is 4/9, and so on. To the n power, how far are we going? How many times are we multiplying by 2/3? Well, it might help to know here that 2 to the 5th power is 32. Similarly, 3 to the 5th power is 243. So 2/3 to the 5th power is going to be 32 over 243. This means we'll be multiplying by 2/3 5 times, but that's after our starting value. So that means there's going to be 5 times plus 1, because we have 1 starting value, right? We start with 1 value, then we multiply by 2/3 5 times. So in total, that's going to give us 6 iterations. So n is 6. Then we'll divide by 1 minus 2/3. Take that over to the calculator, and for part B, this will give us, let me do some erasing first. Be helpful. Of course, there's a more efficient way to do this, but I don't know. Anyway, so in the end, this should give you 665 over 243 whenever you put this whole thing in your calculator. Okay, sweet. All right, so what about the next one? The first thing that you might notice is that on this next one, sorry, I'm just going to erase as I talk. On this next one, this is not a finite series. You'll notice it keeps going forever, right? So there's actually a formula in your book for some of a finite series. I'm gonna, if my computer will let me, I'm gonna erase right here and just write the formula for finite series for you. Whoops. A1 over 1 minus r, super easy. So what's A1? It's our starting value, right? Oh, there it is, -2. 1 minus, well, what's our ratio? What do we have to multiply by to get these numbers? What do we multiply -2 by to get -1/2? It's actually just 1/4. Then -1/2 times 1/4 is -1/8, and so on. So we stick this in our calculator, and we should get -8/3. I think it is also notable to note that your common ratio R, right? R was 1/4. That's actually less than 1, right? If the ratio is less than 1, then that means that this does have a value. It does converge to a value, right? So the sum does exist, but that brings us to our next example. What's our starting value? It's 1, right? So 1 over 1 minus r, right? But what's r? Looks like it's 6, because 1 times 6 is 6, 6 times 6 is 36, 1 minus 6. But we actually can't use this formula in this instance, and why not? That's because r is 6. That's bigger than 1, right? If you notice, this sequence here is just getting bigger and bigger and bigger. It's always going to get bigger, and it's just going to keep going forever, and it's going to get to be so huge and going to go off into infinity. So it doesn't actually have a value that it ends up at. This one does, though, because notice that the parts that you're adding on part C, they keep getting smaller and smaller. So that's why paying attention to the value of r. See if it's bigger than or less than 1. Okay, final problem. It's about an employee that invests in an annuity. So there just so happens, I believe, to be a formula in your textbook for this. And that formula, I'm going to write it over here in red. All right, let's write it in green. I don't write it in green enough. A equals Okay, what does this mean? Well, P is the amount that you invest at the end of each of the compounding periods. And you invest it n times a year, and your interest rate is R. And then basically, A equals the value at the end of all the years, after T years. So I'm gonna erase over here real quick. All right, so let's talk about it. What do you do? Well, let's first start by plugging in the things that we know. How much do we invest each month? Well, we invest 500. So 500, that gets plugged in for P. Okay, well, now we do 1 plus, well, what's R? 5%, right? 0.05 over N. What's N? Well, N is actually 12 because it's compounded, or it's invested per month, right? Over 12. And there's 12 months in a year. So to the NT power, let me do some more erasing. Why doesn't it want me to? Can you tell I've never owned a tablet before? Anyway. So to the NT power, so N is 12, like we just said. T, how many years are we investing? Well, 22 years, lots of time. all minus 1, divided by r over n. Well, that would be 0.05 over 12. All right, so let's stick all that in your calculator, and you should get back 239,677.01. We'll round it to the nearest cent. This means that this is the final amount in the account, right? That's funny. They misspelled annuity here. That's funny. Anyway, that's the final amount in the account. Well, you want to know how much interest you got. So you would actually take away the amount that you invested total, which was $500 per month, right? How many months? Well, it was 22 years times 12 months in a year. And put that in your calculator. 500 times 22 times 12. That's, I'm going to rewrite it here. That would be 13,200. That's how much money you invested. So you'll take that away, and that's going to tell you how much interest you earned, which should be 107,677.01 dollars. There we go. You did your exam review. Excellent job. Now go crush it.